Hi, and welcome for another episode of Quadratic Sieve running on Java. My name is Ilya Gazon. Let's hack. So during the last episode, we improved our metrics to work in real time, but it cost us the price of logs. So during this episode, we are going to improve our logging, and also I'll show you a small bug that I found. Okay, let's hack. Let's create a new episode. Cool. So when I'm increasing this value to a million, the execution time goes above 20 minutes because of a bug in here. So we are updating the base log precision during each time when we are finding a bismuth value, a potential bismuth value. But this value being very precise cost us with this comparison failing due to double precision. So there are several ways to fix it. One option is to do it something like that and check whether it's bigger than some threshold, where threshold is something like this. Another simple solution is just do this. It will be less precise, but it's not a bad thing. It means that we'll just work a little bit more on testing bismuth values. And it fixed the bug. So that's a good thing. Let me show you now. Cool. So the application finished in, yeah, we had the times in here, but ever the sense update, we don't have the times anymore. So let's fix that and also add more logs. We are logging in here. Let's create a new login for that. Not going to do anything fancy, just a very straightforward logger class. Make it even enum. Okay. Now when we're calling for logs, let's move all that logic into logger that log. Right? Let's take those as well. Static. It's available. Logger reflector false. Okay. So we updated this portion and we remain backward compatible with the previous episode. Okay, now we can go into the metrics and update here. Since it's just logging, I'm not going to create a new class for it. Let's just update it here directly. So logger log that and that. Cool. So now let's see how long does our application run. Cool. It runs in 13 seconds while I'm recording. Great. Now I want to add additional logs for .9. I want to actually predict how long will it take for the algorithm to finish. That we can remove. Oh, and this part we can take outside the loop. Because it doesn't change, no reason to keep it inside the loop. Cool. The way of doing that, the prediction will happen here. What we can do is to see how many values, Bismuth values we already found, and estimate how long will it take to find the rest of them. So let's do this test every 1 second. So if system nanotime minus start time nanoseconds bigger than 1 second, then let's do the test. Also create a method here for a getter of the bismuth size. Let's call it get size. Okay. So metrics get size. This is what we found so far. Smooth found out of prime base size. Well, that was true before in the last episode. Now with the optimization where we finishing ahead of time, it would be size perhaps 0.9%, I would say. Right. So this is the total bismuth values. So bismuth values found divided by total give us progress. And we also want to estimate the time. So we have the start time. We can use that. So system time minus start time. This is how much time passed. Pass. Oh, actually, we want to print this every 1 second. So let it not be start time. Let's create another value of start time and last update nano. And let's initialize them when we start the sieve. So start time nano, last update equals nano time. Now it will be last update. And after we do that, and say that equals to the current system time. So the interval, so it enters here every 1 second. And then when we want to see how much time passed from the beginning of the algorithm. So this is time passed. And the speed that we are running with is counted for a millisecond. So millisecond multiplied by bismuth found divided by time path. Let's do it like that. So we work with doubles. So this is the speed in milliseconds. Now we can log completed progress, found total bismuth values found so far, estimated time to finish will be the speed in milliseconds times, let's do it here, the speed in milliseconds times bismuth values minus bismuth found. And we want to look in some integer of that, or long. All right, so now we are going to print all the time how much time passed through the beginning of this script. Let's try this. Right, so the percentages work. It tells us how many bismuth value it found. Yeah, that doesn't looks right. It's not the bismuth found. And then the estimated time to finish is not that. So let me fix it. Okay, so we need to do a division rather than multiplication. And need to print here bismuth found. Okay, let's try now. Right. So now it prints the estimated time. Let's see. It estimated 13 seconds. No, it estimated 138 seconds, which is totally wrong. Then it fixed the estimation to 13 seconds. And then it was more close to the truth. Then our progress was better. Yeah, so those will not be exact because the speed of finding bismuth values will decrease as we will go further, because as we will process bigger values of x, then the chances of finding bismuth value will get smaller. So the speed is expected to get smaller all the time. But nevertheless, it's nice to see the progress while we are working on this. During next episode, we will continue with further optimizations. See you for now.